This is tutorial 5a, question 1d. The question now asks, does the finite sequence have pole? And if so, where is the region of convergence? So the finite duration signals are these. In this example, we have some values from n equals to 0, 1, 2, 3, 4, 5, and then for the values 6 and 7 onwards, the sequence are 0 and remains as 0. So this is a right-sided signal, or called a causal signal. And it's finite duration because after a fixed n in this particular example, the rest of the values are 0. The region of convergence then is actually the whole of Z plane except the origin. Let's see an example. For example, the sequence is 1. This is n equals to 0, minus 3 and 2. We then plug xn into the Z transform. So the Z transform is simply this equation. So we have only n equals to 0, 1 and 2. And therefore we get the coefficients of the polynomial to be the coefficients of xn. And the power at the z's are the indexes of xn negative. So we have 1 minus 3z minus 1 plus 2z minus 2. To find poles and 0, we prefer to be positive powers of z. So what do? We multiply the top and bottom by z squared, such that we have the numerator as positive powers of z. So it's 1z squared minus 3z plus 2 on the top and z squared at the bottom. Now, when z equals to 0, when we substitute z equals to 0 into the denominator of this expression, what do we get? The whole expression xz becomes infinity. So, in the origin, where this is the real part of z, and this is the imaginary part of z, at the origin, there is a hole here. The region of convergence cannot include the origin. What about the zeros? When we substitute z equals to 1, the whole numerator becomes 0. When we substitute z equals to 2, the whole numerator becomes 0. So for this particular example, the shaded region is the region of convergence. We should put x in the origin and times 2 because there are two poles in the origin. And then we should use z equals to 1 and z equals to 2. So maybe here, this is z equals to 1 and another one, z equals to 2. So these two zeros, z equals to 1, z equals to 2, are the 0 pole location. The star at origin with squared is the pole location. The shaded region is the region of convergence for this first example. Let's now continue with the second example, which is an anti-causal signal. Means that the sequence lasts from minus 1, minus 2, minus 3, and in this example, all zeros after that. We can also have a value at n equals to 0 as well in this example. The Z transform of this, let's have a clear example. We have 1, minus 3 and 2. So 1, minus 3 and 2, where n is n equals to 0 here. So this is n equals to minus 1, this is n equals to minus 2. So we only have 3 values in the sequence and the index are corresponding here. We perform the Z transform. Those elements on the left of the origin will get positive powers in of Z because there's a negative n here. So 1z2 is this coefficient, minus 3z1 is this coefficient, and 2 with z to the power of 0 is this coefficient for the polynomial for the x of z. Now, this is already the positive power, so what can we say? Well, the ROC is everywhere except infinity. If you put infinity here, it's infinity minus infinity plus 2. So ROC is the entire z plane except infinity. Right, so when we draw this, we have the entire z plane except z equals to infinity. Now, of course, again, you can factor this to get the zeros location, and in fact, this equation and these equations are identical, so the zeros is at 1 and 2 as well. So we have 1 0, so at z equals to 1 and z equals to 2 are the 0 location, but there's no pole at the origin. Finally, we have the two-sided sequence. In this two-sided sequence, they are finite again. So what happened is that no values exist after a finite amount of time. This is a two finite length sequence. The ROC, of course, is the sum of this, or the overlap, I should say, of these two sequences, and therefore only at z equals to the origin, or z equals to infinity, where the ROC does not exist. The ROC is the entire z-plane except these 2 points for finite duration sequence. So I give you an example. We have 1, 2, 3, 4, 5. Then actually I should write it this way. And then to tell you where the index n is, I have that little arrow to say this is n equals to 0 for number 3. Index 1 for number 4, index 2 for number 5, index 2, value 2 for minus 1 index, 1 for minus 2 index. The z transform of this sequence is this, and now it is obvious that when z is infinity, xz becomes infinity. When z equals to 0, then this term becomes infinity, and this term also becomes infinity. Therefore, again, we realize that ROC is the entire z-plane except at infinity or origin. Thank you.